Hi, this is Dan. I'm bringing to you an experiment for law of conservation of mass. What we're doing here is showing that that mass is neither created nor destroyed when a chemical reaction occurs. How we're going to do this is we're going to take our reactants, which is baking soda and then vinegar in these tubs, and when we mix them, it's going to create carbonic acid. Now, the carbonic acid is going to release carbon atoms and oxygen atoms into the atmosphere in the form of carbon dioxide. So, what we're going to do is first show you that these are measured out and that both experiments, or both sides of it, are equal. So first we have sample A. Sample A weighs 499.4, close enough. And then sample B, all the same thing, the electrical tape, the balloon, the bottle, the vinegar, all the same. It's going to also weigh 'same amount. Okay, so now that we know that both of the experiments, both of the things are equal, we're going to start the experiment. So, and the 490.9.4, that's going to be the mass of the experiment. So since this is the open experiment, we're not going to want the balloon or the tape over it because we want the mass to escape. So hold on. Tape doesn't really matter here. We just need the mass of the tape. So it's the same amount that we put on there, just not going to be on top of it. And then we're going to have the vinegar and the balloon. So now the chemical reaction is about to happen. So we're putting the baking soda into the vinegar. And I'm going to do this slowly, so only the gases escape. If I do this too quickly, we're gonna have a whole, oh no. Alright. Oh, hold on. I don't want the liquids to escape because that's gonna kind of mess up the experiment, because we want to show that it was the gases that have the mass that are escaping. Alright. Oh, shoot. Alright, that's not too bad. Alright, it's going to stay on the scale though, so you guys are going to know that it was still the same. It's probably going to happen again. Okay, well, it wasn't in a closed system, so that's another thing that can happen if it's not in a closed system. It's all mass that you're losing, but you're just not going to be able to see.
It's just human error.
Yeah, kind of. I'm going to come up again. That would be a bummer. Alright, it's taking a while. like half done. Alright. So now the chemical reaction has occurred. Both substances are now in the water bottle and a little bit on the table. So that's going to be the product of the two reactants. And what you can see here is that since the system was not closed and mass was able to escape from the entire experiment, that look, what was now 499.4 is now going to be way less. But for the purpose, I want it to be weighed out for this one already, so I'm not going to find out what the new mass of this is. Okay, so I'm just going to grab the towel real quick. Bobby, would you run downstairs and in the pantry closet there should be more paper towels? It's going to down the stairs right to your right. No. Don't do it? Alright. So, the scale has no more stuff on it. So, now what we're going to do is for sample A. Now you can see this weighs 499.4 as well. But watch what happens when we have a closed system. Alright, hopefully, this doesn't overflow. Alright. What you should see is the gases that otherwise would have escaped from that, the carbon and the oxygen atoms will fill this up. And
quite the sound.
Wonder if it'll stay up by itself. Alright. And now, crap. Alright. So, the balloon isn't a perfect closed system, but you can see that, hold on, that the mass, let's find how much it changed by. And is it too much now? No, it's too little. Alright. So now, the mass of the experiment. Although some was lost because a balloon isn't a perfect closed system, it shows that, hold on. Alright, so now it is at 491, which, again, if we had a perfect closed system, it would have been better. But now, if we do this one, which wasn't a closed system, all it would have lost, it will have lost a significant amount more. We're already going into the, it's lost more than 20 grams so far. Alright, so this one lost like 21 grams because it was not in closed system, and the matter was allowed to escape through it. And this one being, this is all the matter that would have otherwise escaped this, and this is solid. So this one is a closed system, and it prevented mass from escaping. And this one was an open system, and mass escaped this, and yeah.